We start straight away or you all need a 5 minute break or something? Good to start? Cool. So I hope everyone's done with their joke and we're all set to go. So yeah, my topic for today is the Kotlin's multi-platform illusion. So there's a ghost in the compiler. So today I'll be taking you all on a ghost hunt and we'll see if this actually turns out to be an illusion or what exactly this is. Before we start off, I should tell something about myself so that you all feel that all of this is coming from a credible source and I get a chance to boast or roast. Yeah, so right now at Book My Show, I'm the senior Android guys that helps the team manage themselves and the juniors manage themselves as well. And don't ask me for IPL tickets. I was at Rapido previously working with GD's team and we built out the entire app using Jetpack Compose and the latest best practices that cleared a huge tech debt, and it was like one of the most interesting things I've worked on till date. And they just hit 1 million writes per day. So we built that app, super proud of it. Other than that, my hobbies include taking my Harley for a ride, sometimes playing the guitar, and most importantly, going down the rabbit hole. This is what I identify myself as: professional bug creator and an occasional bug fixer. So yeah, since we're done with that, so all of us are haunted by duplicate code. So people in the house, anyone has written one feature for Android and the same feature for iOS and the same feature for mobile web? Anyone? So you know the struggle. And it's not pretty easy, right? It's just a ghost. So we are on a journey to explore a supernatural phenomenon in your compiler. So this ghost promises that you need to write once and it will just run anywhere. But this seems to vanish when you need it the most. And you're just left debugging at 2 AM in the night and you realize that platform differences are real. So why do we actually need to go on this ghost hunt? Duplicate business logic across platforms. So as someone already said that it's a pain writing the same code over and over again. And if you ask the senior folks, code is actually like the last thing you should do. You should not have any code because writing code is just writing bugs, not writing code. So it sounds fun at the first shot, but I'll tell you the challenges associated with it. So this is what you might be thinking, but this is what happens. And your Android and iOS apps are siblings. Anyone having long distance siblings? They're never quite in sync. This is what your code will look like. Another problem is, but it works for me, right? So what's the problem? Why should I even care about the other frameworks? So let's say if you're handling a simple thing as network responses on Android, what we do is we add our retrofit layer, we model the responses and done. And let's say some random day your backend stops sending a particular JSON key. So this should be quick to fix, right? What more can it be? Just go and add that key in your retrofit JSON response and start consuming it. That's it. But the trouble is this. Let's say if you ask the backend to add something, you now have to go to the other platforms, ask them to honor that as well. And it's just a whole deal of random dealing with a lot of stakeholders, which is not that great. So if I did a push-up each time I rewrote code, I would have had strong biceps. So this is what basically you would feel like, that Android says that the code works, iOS says no it doesn't, backend says it should definitely work, but the PM says that the requirement has changed. So introducing Kotlin Multiplatform, the course in the compiler. So even though I call it a ghost, it's science. Well, it's very ironical that ghosts are being related to science, but it's just science and a little bit of compiler wizardry. So if you see in this diagram, we have a common multi-platform layer and we have a client multi-platform layer. So you can share as you go. You don't need to kind of you don't need to share everything all at once. You can just decide how much you need to share in your layers. Whether, let's say, your server is sharing some kind of code with your Android app or your iOS app, let's say some database calls or whatever is being shared. So Kotlin multi-platform brings you that flexibility. It is suitable for all kinds of projects, as I said. So you can just decide that your app is already written and you'll just share a piece of your code, let's say some kind of critical logic that you're building fresh. You can write it in Kotlin, that's your small little K over there. You can share your entire logic if you're writing like a new logic. Let's build a logic layer in Kotlin, UI layer will be, let's say, Swift UI, UI Kit in iOS or Jetpack Compose in Android. Or you could just share your entire code. So there is something called as Compose Multi-Platform or CMM. So using that you can write your UI once and it just renders as you expect on all the platforms I showed above, that is Android, iOS, web. While this is still in beta, there is like a lot of proven examples that people have done. People have built out small POCs, like let's say in the morning Rajesh showed us a wallpaper app. So something like that, you could just write code once and it will just run seamlessly everywhere, even on the web. So that might be a good use case for your company or your project. So I'll just describe the illusion a little before we proceed to the code building. So this will be your KT file. This is your Kotlin compiler, the course that we're talking about. And this is your JVM bytecode. So this is usually how the compilation process looks like. This bytecode is later taken up by all the platforms and just got to run however they're supposed to run. So we are looking at the center element. So this Kotlin compiler has two things, that is your front end and the back end. So I'll just give you a very brief detail about these layers, not going to complicate it a lot. So they share something called as the IR code, which is an intermediate representation code. So your front end of the compiler will read the Kotlin file, it will generate an IR code. Your backend will read that IR code and generate the JVM bytecode. Clear till here? Any questions? Yeah, so let's see the front end side of things now. So this is your front end compiler. This has version K1 and this has version K2. So basically K2, if you all have not heard, is the most recent offering, that is Kotlin 2.0. It promises up to two times faster iteration and build times over K1. You all have special dedicated modes in the IntelliJ JetBrains IDEs that can make code parsing faster. Like that's up to 2 times. And they have also upgraded something called as KSP. So KSP is like a Kotlin only or a Kotlin native annotation parser. So yeah, that is about it. Now let's look at the backend side of the things. So your backend compiler, this has a native compiler written for Android. Then it has a compiler written for iOS. for WASM, and this is JS. So how many of you all know what WASM is? The one thing at the top left. Anybody?
Web assembly.
Yeah. But do you know what exactly does that do?
It gives us the website. You can create the website for that.
Yeah, but do you know how does it work behind the scenes? Obviously, that's a mechanism writing web code, obviously.
I usually just I did in Compose that GMP.
Okay.
I write a code in Jetpack Compose and just run it to the create website.
Okay.
Only that.
But then how is that different from your JS compiler? How do you know if the JS compiler worked behind the scenes or WebAssembly?
There is thing called as DSL.
Okay.
Which converts to the.
Yeah, but which exactly would that convert to? Which compiler, like the DSL will be passed by some compiler, right? Which compiler would that be? Which of the two? Because both are meant for web.
Yeah, I didn't work on DSL.
Okay. Anyone else? WASM, this guy on the top left? No? Okay, cool. I'll tell you. So WASM stands for WebAssembly, as this sir pointed out over here. So basically, it's just a new type of bytecode that you write for the web. It compiles directly into your JavaScript. Using JS, if you use the JS compiler, it actually runs through a bridge and it's a little slower. If anyone has written React Native code, you all already know that it runs via JavaScript bridge and it's very hard to kind of work with, especially in terms of performance. So WebAssembly is your alternative to that. It's a way faster variant because we write assembly code directly. So any of you all have written assembly code ever? With registers or something like that?
And college days.
Yeah. Cool. Yep, what was that? Yeah, so each of these works with the common IR to ensure the consistency on all the platforms. As we saw the diagram, there is a front end and a back end. That is the part of the compiler. So the back end is internally written into all of these targets. There can be in future more targets. So they will automatically write their own targets based on that. So this all is capable of reading the IR and converting it into the JVM bytecode. So I think enough of all of the theory. Let's go see some code. This is what I've written, and to write something like this, all you need to do is go to kmp.jetbrains.com. Here you get a template creating mechanism. Let's say you can call it XYZ. Then you get to select your targets. Right now we are just targeting Android and iOS. That's the code that I have already checked out. And you can share the UI with Compose multi-platform or do not share with UI. So I have used this option. I have not targeted desktop, web and server currently. So usually this is the way to get started. Once you do that, you can land directly with this structure. So I just got the news that the Android Studio version that was announced yesterday, Meerkat I guess. So that allows you to actually create a new module straight up from Android Studio. So you don't need to go to that website anymore. You can just add that. But yeah, coming to this project, we have like a Compose app directory. This is your main entry point into the app, the current app. Then we have iOS app and then we have shared. So basically your Compose app will contain all Jetpack Compose related code, very obvious. Your iOS app will contain code related to iOS, again very obvious, and your shared app will actually contain all the shared logic. So first, let's start exploring the shared app. A typical structure. So if you see, there are 4 targets over here: Android main, common main, iOS main. For the native main target, I'll come to it later. I'll just explain this is a special kind of a target or source set basically. So yeah, let's just jump into the Android code. Here what we have is a platform.android.kt, which is your implementation of a platform class. You have a class Android platform which implements a platform. This looks like to be an interface. So let's just kind of go to this interface where exactly this is written. So I just did a command click and now I'll just locate where exactly this is. So if you'll see, this is part of the common main. So this is just an interface with a particular name. Okay, so we've just kind of grouped data over here saying that there is an interface and it needs to have a name. Now, we also have something called as an expect function, if you see here. Here you go. Yeah, so this expect function is actually where the beauty of Kotlin multi-platform starts. Again, I'll get to that in a bit. But for now, you can just remember that each expect function needs to have an actual function. So if I click on the gutter over here, I'll see that there are 2 actual implementations for it. Which one do I actually want to view? So this main is the one that is related to Android. It's just called main. They've given a symboling for it, and iOS main is the one that stands for iOS. So let's go to this one. What I've done is, for the expect, I have an exact same signature of the function called as an actual function, which creates a new class called as an Android platform. So this Android platform is your implementation of the platform interface, and for the name, it just says that this is Android and this is the SDK version. A similar version will exist for iOS as well. Let me just jump back to the shared code and yeah, from here I'll just go to the iOS version of it. So if you see, there is a similar class that implements platform again. While overriding the name, it just says that it is using something called as a UI device, and if you see, this UI device comes from the UIKit package. So this is like a very iOS specific code. So yeah, this does the same thing. It gets the actual function and it determines your actual class, that is your iOS platform. Cool. So this is what your structure looks like. Now let's go to the iOS app part of the directory. This was all your shared code. Shared code still has some bifurcations for Android and iOS as well. This iOS app, this is just like your typical iOS project. If anyone has worked on iOS before, you will just notice that this has something called as an Xcode project file. So if has anyone done iOS here? Anyone experimented with iOS? So you know what that Xcode project means, right? Yeah. For the people that don't, Xcode project is your Xcode version of your .kt file. So this just gets all the project related information Xcode gets from this file. So once when I launch the iOS app, which will be in just a bit, I will just launch using this file. Enough for this iOS app directory. Here, when you come to the Compose app, we again have 2 targets, that is your Android main and your common main. So your Android main just contains a typical Java structure. Yeah, and it has 2 files. One is your app.kt. This is your launch point of the Android app. If you see, we've just put in some Jetpack Compose related code. People familiar with Jetpack Compose over here? Yeah. All of you? Yeah. So this code does nothing but just shows a button. If I click on that button, it will just launch a Compose wala logo. Okay, that is all this code does, even if you don't know Compose. And this is your main activity, which has your set content, and set content mein we call that app. Okay? And something similar will happen on the iOS app. यहाँ पे we have a iOS app.swift. Yeah. This is your content view. This is your launch point. Your @main includes the launch point of the iOS app. And your content view.swift, this is Swift UI. VStack is your column. And there's no, your text is just like your compose text. Your image is just like your compose image. So that's all you need to know. This has a similar implementation. If I click on a button, it will just show me a Swift logo instead, not a compose logo. And if you see, there is a common main over here inside the compose app as well. This contains resources. So if you want to add some kind of XML, some kind of logos, you can use that over here. Yeah, I think enough of all the explanation. Let's give this app a run. I hope this runs this time. Rajesh is gone. Uh-oh. Okay, just a minute. Let me get my hands dirty. So what I essentially did here was just added a val, that is your random number, and this is an actual function. And as I said, expect and actual functions always go in pair. So I have a platform expect value as well, which is a random number. So a random number, we need to generate a random number. You've already guessed that from the variable name. So this has two implementations. One is inside the native main and one is inside the main. The error was because it was not finding this. I had just commented this out for a demo, but seems like we'll need it right now. So I'll just explain it right now. Just don't worry about native main. Once I get back to a little bit of theory, I'll just tell you. But native main covers for iOS this time. Just remember that. So let me just run the app. While this runs, so far so good, right? Anyone has any questions? Anything that you didn't understand? Cool. So here is my app. I'm not sure if we can zoom into this. Yeah, there is this button. Yeah, if I do a click me over here, let me just go and minimize this window. Yeah, if I do a click me over here, all it does is launch a Jetpack Compose window, and it also tells me a random number that I generated earlier, saying it's there from Compose. Now the tricky part here is you could launch an iOS app from here as well. This is made possible with the Kotlin Multiplatform plugin that I've already installed from JetBrains, but this doesn't seem to work because the stable Kotlin Multiplatform hasn't been hit. So I wish this could work. It would have been as simple as just clicking the play button over here and it would have just launched. But obviously, because it's Apple, they will make everything proprietary. Let me just go and open this Xcode project in actual Xcode. I'm not sure how much time this is going to take. I hope it's quick. Yeah, that is nice. Let me see if I can launch it. Waiting to build. Yeah, we have a play button over here as well. So it's installing to an iPhone 16 Pro. Here's my simulator. So iOS development is pretty similar to Android as well. The first long takes a huge amount of time, but then subsequent loads are really quick. So if you see, this is just saying it's stuck on installing. I hope it gets done. Yeah, it is launching it, attaching to the process. I have written no code for this. Has been launched and it's ready. So if I do a click me over here, you will just see the Swift logo with the hello and a random number being generated. I will explain some theory based on that. So yeah, let's just go back to the slides. So yeah, I had some section before we went to the ID. Nevertheless, let's cover it right now. So yeah, we always need to remember to visit the doctor timely. You may never know what kind of issue you may have. So this is a special plugin called as K-Doctor. You can find it on Brew. If you use macOS, you are definitely familiar with Brew. macOS users in the house. Yeah, cool. Best platform to write code on. So if you see, this is the screenshot I've taken from K-Doctor. I just ran K-Doctor and it actually told me what exactly needs to be done. It has a checklist for Kotlin Multiplatform mobile plugin, checking if Xcode has been launched and all of this download that you see over here. If you launch Xcode for the first time, this is the window that you're going to see, where you will have to download the emulator and all of that. And you need to have Cocoa boards installed on your device. That is a must for iOS development. And you need the Kotlin multi-platform mobile plugin as well, which helps you launch the iOS app. It didn't work for me, and if you see यहाँ पे, it doesn't recognize that I have installed it, even though I have. Looks like there is some kind of debugging, or there's some kind of problems with the plugin. And you also need to have a really good internet connection. Because if you see, with an Xcode, you need to do a download of 9 gigabytes. This is your iOS simulator. If you don't have the simulator, you won't be able to launch your app on iOS. And if you don't have a MacBook, this is what will happen to you. So you need to have a MacBook. So having a MacBook is so important that the JetBrains wale guides don't have any guides for any other platform. I don't know why they decided to do it. But your basic guide starts with brew install something. So they just assume that everyone has a MacBook. So yeah, there you go.
Xcode नहीं चलता है ना.
How but you can still build on Android. Why force someone to use a MacBook? Anyways, the curiosity may kill the cat. And this is what happened when I was building that app for the first time. If you see, it took me a whopping 21 minutes. And this is Android Studio powered by the M1 Pro. I need to get it checked. And finally, yes, before going to the ID, this is, can you guess what do you need? That's right. Yes. Anyone heard this legendary dialogue? हेरा फेरी सबने देखी होगी ना? याद है कि नहीं? ठीक है. So let's start with this phone call where this guy asks, "Hello, Devi Prasad है?" So this guy expects Devi Prasad, right? But it turns out to be Baburao. And this keeps on happening. So expectations and reality. But yeah, let us adopt this concept for Kotlin multi-platform. As I said that we have an expect and actual pair of functions. Abhi exactly kya I'm going to explain that over here. It expects, as the keyword says, like a specific type of class, data or whatever. So this is your basic syntax where I'm creating like an expectation class. I'm naming the function expecting something. Yeah, and next part is actualizing it. So Kotlin peeps have like a term for it. Like if you have an expect function, you need to actualize it. So the actual function comes into the picture, which provides the actual implementation. So like we already ran into a random number error, right? So the compiler actually gives an error if you specify that there are some platform in the source set and I've written an expect function, but for that expect function I need to write an actual implementation on each of the platforms I'm going to target. So exactly what a source set is, I'll come to that in a minute, but yeah. So this will be your actual function. This is my expectation, and you can always fuel your expectations. There's no cost to it. So expectations always hurt because this is what I expect from AI and this is what I get. But yeah, getting back to the IDE for a little bit of more code. Let's just give you a brief walk around of the expect actual functions again. So this was an expect random number integer. If I dive into the implementation, I have a main which says that random.nextInt. This is imported from Kotlin.random. And if I go to the native main, the other actual expectations for it, this is native main. So again, just don't want to keep denying what native main is, but yeah, I'll just get to it again in a bit. But this has the exact same implementation because this actually has access to the Kotlin package. But if I were to write something like this inside your iOS side of stuff, let's say if I were to copy it right from there, like an Android developer's expectation would be that yo, it will just work, but yep, oh, it does work. Yeah, I am not sure how, but okay, cool. This comes from random. Kotlin is probably available on iOS wala stuff as well, but yeah, here random is probably implemented for iOS as well. But if there was something like, let's say, UI device where you need to get like a UI device name or something, you would actually get it from UIKit. So यहाँ पे we actually need to have a particular dependency already implemented for iOS, या फिर we'll have to call the native kind of code from iOS. यहाँ पे random is already implemented for Kotlin. I was not aware of that, so it just works. So let me remove this. But did you all actually notice that even if I deleted the code and if I go back to the expect implementation, it doesn't give me an error. But if I remove this from Android, let's say if I comment this out, this gives me an error saying that expected property has no actual declaration in shared main. Your shared main is your Android. So, but this didn't happen for iOS because we have native main saving the day for us. So yeah, before I get to native main again, let's get back to the theory again. So continuing with the Hera-Fairy meme templates that I've set up, or the storyline. Do you know that iconic dialogue where you see that there are three nulls? तीन नल है. तो एक गर्म पानी का नल है, ठीक है, एक ठंडे पानी का नल है, ठीक है, और तीसरा नल किसका है? तो यहाँ पे वो है नहीं, ये वो तीन नल है. तो बेसिकली your source set is that sorcery और वो हेरा फेरी वाले 3 नल बेसिकली जो अलग अलग सोर्सेस से पानी देते हैं, अलग अलग टाइप का पानी आता है, सॉरी. एंड व्हाट एग्जैक्टली इज दिस सोर्स सेट? इज इट सम काइंड ऑफ सॉर्सरी? सो व्हाट इज अ मशीन वाली डेफिनेशन? It contains Kotlin source file that participates in compilations together along with resources, dependencies and language setting. So in simple terms, it's just your null. It gives you ठंडा पानी, गर्म पानी और no पानी at all. ठीक है? एकदम simple. उसका syntax is something like this. So your target main and compilation name has 3 source sets. The common main that I already showed you, that is applicable to everyone. Your iOS main is applicable to only iOS and JVM main is applicable to JVM targets. So as we said कि target कहाँ करना है and कौन सा version करना है. अभी common main के साथ एक common test version भी होता है जहाँ पे you can write your test similar for all other variants. So target source followed by कहाँ which exactly do you want to target. और कितने सोर्स सेट थे? सो जस्ट लाइक बाबू भैया वाले 3 नल, वी हैव कॉमन मेन, देन वी हैव एंड्रॉइड मेन, वी हैव iOS मेन. दीज आर ऑल, आई एम जस्ट डिस्क्राइबिंग द टाइप ऑफ सोर्स सेट्स देयर आर. दिस इज योर macOS मेन. This is your watchOS main. So iOS, watchOS, macOS. So there are more bifurcations. So iOS main has ARM and x64. So the new MacBooks are built with the ARM architecture. The older ones were with the x64, and same is applicable for the Apple A series chips as well. They changed the architectures. And there is something called as native main, just the thing that I was talking about from quite a while. So this is a special type of source set that we call as an intermediate source set that covers the implementation for all of the 3 platforms. So that's why when, if you remember in the code, I didn't write anything for an actual definition of iOS, but still the compiler didn't give me an error because this guy over here, this is your common source set. This is your platform specific source set, and this is your intermediate source set. Sorry, the text is getting cut off, but yeah, the intermediate source set. This is the one that saves your day. So what happens is, you might be wondering that, okay, if I write the implementation again, what will happen? So your platform specific source set is actually overridden by your intermediate source set. So if I write the random number code in iOS, it will be overridden by your intermediate source set. And when the actual compilation happens, the compiler automatically is supposed to just manage your expect and actual and combine the code. It will do the signature level checking for you. So that's why the native main intermediate source set is very important. And in fact, it not just covers the iOS set of targets, but it also covers JS, and it also covers the targets where we saw the Kotlin native wala compiler. So I think that is your JVM wale targets, your Linux targets, and like desktop apps is also covered inside native main. So let's address the skeptics. Oh wait, before that, let me just kind of go and show you the Gradle file. This is the shared module वाला Gradle file. यहाँ पे भी this is how we define the source sets. So if you see, यहाँ पे वो common main जो मैंने बताया था उसका dependencies डालेंगे हम, if there is any. यहाँ पे you have access to a whole lot of other source sets. Let's say if it's iOS main, then we have native main. These source sets are pre-made for us. So any kind of dependencies that you want, you can just add them here. This is your Android configuration block. This is part of all Android projects. Android developers already know about this, so not covering this. Then there is this Kotlin block. This is your Kotlin. This comes from your multi-platform plugin, जो मैंने यहाँ पे apply किया है. this one. Then we customize that multi-platform plugin and we add targets to it. तो target is your target platform. तो यहाँ पे मैंने Android target लिखा है, उसमें मैं कुछ compiler options दे रहा हूँ. Then I have all of these iOS targets, जहाँ पे I am trying to create some kind of a framework. So this framework is called a shared framework. So if I don't create this framework, I cannot compile all of my code for an iOS app. So if I go to Xcode and if I show you the code, ये shared वाला जो code है, here if you see here, we have imported the shared wala code. I'm not sure if this zooms. No, it doesn't. Yeah. So here is the shared wala module that we created over there. Sorry, framework. So this is what it creates, and let's look at the Gradle file inside Compose app as well. We have a similar structure over here. यहाँ पे we have a common main actually declaring all the Compose dependencies, and we have Android main just declaring the Compose preview, because this project is already halfway set up for Compose multi-platform, that is sharing your UI on writing your code in Compose and sharing it across both Android and iOS. That's why all the dependencies are inside common main, so that they can be accessed by both Android and iOS, and only preview is Android specific, so it's part of the Android main block. This is again Android specific configuration. Yeah, this is your native main folder where we actually wrote the random number logic. This will apply to the iOS platforms. This is your file level build Gradle file. So let's say tomorrow if I'm creating some kind of new platform and I need to create a custom source set, like custom kind of code sharing mechanism. So this is what I'll have to do for that. So this is a special syntax, custom source set by creating, and all then I have to do is custom source set dot depends on Kotlin main. So basically I am creating a custom source set that depends on common main, so that already gets your dependencies from common main. It can also have its own kind of dependencies. So your native main is basically that, like Kotlin has automatically said that your native main, your iOS targets and your macOS targets will depend on native main. ये जो depends on लिखा है, this is internally done for the native main. This is how you will create your custom source set. So let's say you have a JS and some kind of platform and you want to share code, you can have your custom source set and define it as you like. So you get the customizability. Now, the myths and realities associated with the implementation of KMP. So we already have KMP, already have Flutter and React Native, right? So why do we need another kind of framework? So I think it depends on your preferences. What do you like to write? Kotlin, Dart or JavaScript? I think all of us love Kotlin over the other two languages, right? Yeah, so it just depends on what do you like. So this is just a surface level overview. I'll get into the details as well of which framework is better at what. So would you like to adopt a new framework incrementally or break prod directly? So depends on how much risk you can take as well. So KMP actually shines here because it gives you the power to share code as you will. As I said that you can either share the entire code, just share a section, or you can take that approach basically. Depends on your team strength as well. So if you have a small but agile team and it is capable of learning new technologies, mastering them and doing it well, why not adopt it? But KMP has the edge over here because Android developers don't have to learn it, but iOS devs have to. But yeah, I'll address that as well later. your time and money investment. So your global vision that is determined by your product guys, your co-founders, your owners, does it benefit from this approach? For example, let's say if I'm building Farm Easy, something like a medical app that just fetches something and just shows the data. Let's say I'm fetching all the list of medicines and showing it for the user to buy. It definitely makes sense for me to write it in a multi-platform fashion, because worst case, what could go wrong? I mean, the API specific stuff is the basic thing we can do on anything, and we should be able to do. So in that case, if I have a, let's say 20 people team, 10 write iOS, 10 write Android, but then only 10 will be required to write that React Native version of Farm Easy, then it is definitely a good approach. But again, it depends on your global vision. You could also already use the team expertise, as is the case with KMP. And does KMP or having a hybrid framework make the app slower? This is like the skepticism of a lot of people adopting some kind of new framework. So as I said, we have backend compilers written specifically for each target. So you don't need the JavaScript bridge like you do with React Native, and you don't need additional expertise to master performance. It can also use the existing UI technologies, like you can use Swift UI, you can use UIKit, and you don't need to be like Flutter, which has its own rendering engine, Kia, that renders pretty terribly. It has improved, but I'm not sure if it will get as close to KMP or as close to native ever. So this is like some kind of benchmarks. यहाँ पे what I'm doing is I've taken the app built using all the three technologies. I am measuring the minimum, median and the max startup times. This is just sourced from a GitHub repository that compared all of these times. This was like 1 year back. I am not sure if a lot of stuff has changed already, but yeah, good enough insights. So if you see, native Android has a median time of about 415 milliseconds. This is your launch time. Maximum of 425 milliseconds. Your KMP Android is very close in terms of the median, and still very close, I would say, in terms of the max. Your Flutter Android is like really bad at it, and the minimum time goes to 600 milliseconds. That is almost 1.5x from your expected, or somewhere it should be close to native, right? But it doesn't happen. And if you see this is super close to native. So I think this could be a good direction to maybe start exploring KNP. Who knows? You might benefit from the framework. But yeah, the iOS devs hate Kotlin. If you've been in a team and you've tried to pitch them like, hey bro, let's write Kotlin, come write Kotlin with me. They're gonna hate it. They will rather say, come write Swift with me. So Swift is actually super similar to Kotlin. This is the argument that maybe you can use. And it doesn't take time, honestly, for someone already knowing Swift to learn Kotlin. I am not sure if we even have to learn Kotlin, because a lot of stuff is super similar. And Swift in the recent version has been taking so much inspiration from Kotlin. Like Swift 6.0 has so many features that are just like Kotlin. So I'm not sure if they will be like, someone will just switch from writing Swift to Kotlin in a breeze. No learning required. And maybe it's possible that they don't even need to learn Kotlin. Maybe just call a library, like just like you import something in Java, you don't need to write anything in the library. And there can be a separate team again that develops just Kotlin multi-platform solutions, or maybe a section of your Android devs that can actually specialize in this technology, create the frameworks, ask the Xcode guys to just abide by the protocols and implement it. So just for comparison, anyone recognizes this code?
Yeah.
Compose folks, the savior, lazy column. It saved us from 3 files of code of recycler view. So obviously everyone should be grateful to this piece of code. But yeah, basically what this does is just renders a list of texts. This is what happens in Jetpack Compose. And if you see, something similar is available for Swift UI as well. So if you see, यहाँ पे we are doing var body sum view, where I'm putting a list, I'm giving it a padding and a text, which is exactly similar to that. So like people who are first time readers of this code, do you think it's difficult? It would be difficult to understand, even if I wouldn't have told you what this does. It's super easy to read and understand, right? So yeah, if you tell your iOS devs you can still write in Swift UI, maybe they're convinced. So the saga of success is real life adoption of KMP that has already been done. I think KMP was announced 2 years back and people have been pretty solidly adopting it. And here are some of the names that have. Netflix. So Netflix has something called as an Hendrix SDK. It manages A/B tests and helps each user see personalized content. How many people binge watch series? I mean, all of us, obviously. So if you start watching something, the recommendations change, right, for each of the person. So this definitely involves some kind of code, obviously on the back end, but on the front end as well. Switching UI, maybe showing you certain version of the UI that person B wouldn't see. So all of that comes under A/B test. So this SDK should manage content in such a way that should be similar for iOS and Android. Otherwise, your A/B test metrics might be affected. So they observed about 50% reduction in code due to this shared SDK model. I mean, 50% is a no-brainer. Obviously, your effort would be half just by adding all of this platform-specific logic in the Hendrix SDK. And it also keeps the door open for them since they say that we have a large appetite for exploring technology. So it keeps stuff open for them because KMP is adopt as you go along. So you can just decide the exact amount of code that you want to add. Book My Show. Yes, we've been doing this pretty recently. Don't have a name to it as such. So there is a backend driven analytics approach. Basically what we do is we have a very dynamic kind of analytics mechanism where let's say some team says that we want to integrate this SDK because there is some kind of benefit it's giving us, maybe the cost benefit, maybe the feature benefit, and they'll just come as yellow SDK and do the POC on it, put it in the app. So with this kind of evolving mechanism, we do something called as a backend driven analytics where we get the exact data that we need to fire from the backend in an API response, but we as the front end people decide when to fire it. Let's say if there is some kind of dynamic data, I click on a button, I decide that on click of the button I want to fire this data. So this data that comes from the backend can actually change anytime. That is what a backend driven approach is right now there at Book My Show. So for this, obviously the business logic is supposed to be similar. Let's say business logic could mean that for a specific event I want to whitelist it. Let's not fire this specific event for some time. Maybe we don't need to track this anymore. So all of this is possible via backend driven approach where you don't kind of send the data for that particular event, and this should behave the same for Android or iOS. So we are still experimenting pretty early on this. I think the PR was raised 3 months back. It's still not merged. We are still reviewing it. We're still educating the team about it. So in the future, if this goes live, I'll definitely tell you all what my experience has been. Shadi.com. This guy, I'm sure you've seen him on Shark Tank. They are completely sharing the code with UI, and I've obtained this information meeting people from Shadi. I met one of their lead architects and spoke to them about their KMP adoption. They have an Astro app, which is like an astrology app. Let's say you match with someone, this Astro app can actually help both of you align your stars. This is their latest in-house creation. I'm not sure if I'm revealing some business secret, but it's not out yet. But yeah, that is 100% code written in Android and iOS using KMP. That is your Compose multi-platform. Basically, it's just a set of API calls, and I'm assuming that's why they decided to do it. They have also made other code-only modules. like logging. Logging is common, and obviously it's like just the basic thing. Take the output stream and just put some kind of something out. Then there is McDonald's, peri peri fries. So yeah, they are writing navigation with KMP and some business logic. So if you've traveled around the world, you will know that McDonald's has a veg specific menu only for India. But outside they have most of non-veg menu, but it just keeps differing with content, with country. The content keeps differing with country, and they just keep the common items or the famous ones across all of their destinations. So to achieve this, maybe let's say someone who's there in the McD app and who's trying to order it, something like what the Hentix SDK does, just download some kind of content from the backend and make it work. Maybe the backend is applying some personalization or whatever kind of logic, maybe some localization. So if there is some kind of similar business logic, why not share it? This is what McDonald's did. I read this from their blog. And at this year's Kotlin conference to be held in May, they are actually going to describe about how they did navigation with KMP. I am like really looking forward to that talk, because I'm not sure, like, sharing navigation is pretty challenging, because you may not know like the exact screens. Maybe you don't have the exact screens that you do on iOS that you have on Android. So I don't know how this works out, but yeah, maybe all of you all should check it out as well. Geo Cinema. So recent merger with JioStar, but I'm still using their older logo. I hope the Ambanis are not behind me. Anyone remembers the domain buying controversy? So yeah, I hope. Yeah, they have a lots of shared code as well. This is also another information I've obtained by talking to people I meet across. One of the people that was working there was Rebu. I don't know if you have met him or not. He's pretty active across channels. He's a GD in Kotlin. So he told me that. So he has been working on logging. Then they did the network stack as well. So only keeping the platform specific parsing, some kind of code that is being done, but the API calls are common and sit in a common layer. Yeah, I think, do you think it's an illusion after all? Like, is the ghost an illusion? Is the Kotlin multi-platform capabilities an illusion? Well, remains to be answered. And we did hunt the ghost, right? Even though it caused a power cut, we did hunt the ghost. So that's it. Any questions? The forum is open for questions. So I think maybe everyone was dozing off while I was explaining, or I explained it so well that everyone understood it. Either of the two. Sure.
For the web and desktop app.
Sorry?
For the web version, the desktop version. I can design the UI in Compose.
Yes, definitely.
And same, suppose I can.
Yes.
I can have the model and Compose everything.
Yes. And in fact, there is a Compose for web, a framework called as Cob Web. You can actually write HTML like you would do using DSLs. Like if I were to tell you, if you usually write your HTML head tag, they have a Kotlin DSL for that. So if you write head, you can write H2, put a bracket and just write code. Similar for Compose. So you can actually write your HTML content in Compose. It will re-render it to HTML automatically. Like it's that good. But it's still in beta, like that part of it. The Kotlin part is stable, but the Compose part is still in beta. They are figuring out how to render it. Questions? No questions? Cool then. That's it from my side.